All right, we're going to go ahead and get started. This is video 10.2.1. It is the second standard. Our first standard for this unit was on inverses, and because that's going to play a big role when we talk about exponential and logarithmic functions. So it was a big introduction to the chapter, but now we're going to get very specific and get into exponential and logarithmic functions. And this one is an intro to exponential functions. Once we understand what an exponential function is, then we'll get to graph it. But we really have to understand where it's coming from so we know that its nature and we know how it's going to act when we graph it. So that's what we're doing here. We're defining what is an exponential function. So I've written one form. There's in the textbook they use the letter A instead of B. I'm using specifically B because that represents the base. That is the base of this function, like the base of an exponent expression. So it is defined as if B is greater than 0. So it must be positive, okay? So we need to write that in parentheses. Greater than 0 means it must be positive. And it cannot equal 1. And we'll explain why. Then this function f of x equals b to the power of x defines an exponential function with base b. Okay, so I chose B, the book chooses A to represent the base. We also use A as the coefficient that goes in front. So again, that's why I did not choose A like the textbook did. But if you look in the book, it does use A to the power of x. The point is that the exponent is the variable. The exponent keeps changing. So think about something. If you take any base B and you start with an exponent, let's say of 0, and then you take the same base and you raise it to the first power, you raise it to the second power, you cube it, you raise it to 4.5 power. So you can see what might be happening. Well, depending on the size of B, meaning is B a whole number like 5 to the 0, 5 to the first, 5 squared, 5 cubed, oops, that was about 5, then we can imagine what's happening to this as we keep changing the exponent but keeping our base the same. What if B was a fraction? B was 1/2 to the 0 power, or 1/2 to the first, and 1/2 squared, and 1/2 to the third. So imagine what's happening when B is a different number, but in the same sense it stays the same, you just keep changing the exponent. So depending on the base, we could see perhaps a different type of growth. Alright, so in this case what we're going to do is we're going to be using f of x equals 2 to the power of x and g of x equals 1/3 to the power of x, and we're going to kind of explore this. So you might want to grab your calculator, especially for the ones that have decimals, because we're going to be looking at how the different inputs affect the output. So let's go ahead and try these. For the first one, we're taking 2 and substituting, so it's 2 to the power of 0. So anything to the power of 0 is 1. In the next one, it's going to be 2 to the power of 4. And we know that that means 2 times 2 times 2 times 2. So that's 16. Okay, in this case, so some of these we don't need, but definitely the one with decimals, we're going to need it. In this case, I'm going to have 2 to the power of -2. Now we know that means we're going to square 2, but it also means we're going to flip it over. So this becomes 1/2 squared, which is 1/4. And I do expect you to write it just like that. You don't have to have this intermediate step, but it shouldn't be written as a decimal, and it should not be written as 1/2 squared. You can simplify it. Okay, the next one. So here we've got 5.2 as our exponent. So I'm still taking the value of 2, but I'm raising it to the 5.2 power. So this isn't something where I can multiply 2 to 2. I've got this decimal power. So I'm going to go ahead and use my calculator, and I'm just raising it to that power. And I came up with 36.2 3.758, and there's quite a few more decimals, so I'm just going to round to 3 decimal places. I think that's what it suggests in the text as well. Okay, for the next one, I'm using the g function now. So I'm taking 1/3, and just as it has, I need to use parentheses, raising it to the -1 power. Well, this simply means that I'm going to flip it over. So I get a +3. Okay. Now the next one, I have g to the 4th power. So I take, g of 4 means 1/3 to the 4th power. That means 1/3 times 1/3 times 1/3 times 1/3. Okay, well, my denominator is 3 times 3 times 3 times 3, or 3 to the 4th power, which is 81. So 1/81. Again, I don't want a decimal. For the next one, I've used the combination of them. So I have 2 to the power of 5 minus 1/3 to the -2nd power. So I probably want to simplify these each individually. The first one, 2 to the 5th power, is 32. And the second one, think about what's going to happen here. I've got a 1/3 to the -2nd power. I have to square it, and I have to flip it. So that means that I'm going to have 9. So 32 minus 9 gives me 23, and that is the final answer. All right, so we're going to get to practice a little bit more of this tomorrow, and we'll talk about some of the restrictions that we have, such as the base has to be greater than 0, and it has to be, it cannot equal 1. So we're going to talk about why those two things are. So kind of think ahead as to what might be the reason why we have those two restrictions. All right, great job.